Hi everyone, today we will go through commonly used 5 types of regression. This video is originally based on my article 5 types of regression in just 45 lines of code. I have put the article link in my description. So let's get started without wasting much time. We will load our dataset avalon.csv publicly available. However, I have put all the resource link in my description. Load the dataset using iLocation, filter, subset the dataset except the last 8th column to X data frame. Similarly, we will use iLog to define the target Y variable. Encode the categorical data. Remember, whenever you have more than 2 categories, assume 5 categories, then you have to select one less than 5. That is n-1 equals to 5 minus 1 equals to 4, else it will give you NA output. Rethink again, when you convert a 2-category variable like gender, male, female, the output will have one column that will contain 0 and 1 values. 0 for male and 1 for female. The same goes if we have 5 classes categories. We will have 5 columns as output, but remember each column have the response of 2 variables, 0, 1, yes and no. Thus, we will remove one column to indicate all the 4 variables assumed from 2nd to 5th output, or in respect to the 1 variable, assume the first variable. In other words, it means the value of the first variable is already included in all the 4 variables. So, to avoid the dummy variable trap, we will move the first variable or any of the country columns. Assume multi-class column country having 5 classes. Of course, any doesn't mean any other variable output outside the country columns. Next, we will split the dataset into train and test dataset to train a model on trained dataset and assess its performance on the test dataset. Load the function linear regression, feed the linear regression to X train Y train and predict it on the X test dataset. Now, what does the fit in linear regression refers to here? It means we are trying to fit our data in the regression line. Then to view the intercept and its coefficients, we will call the model and the functions. Remember the linear line and the formula y equals to mx plus c plus e, where m is the coefficient and x is the independent variable, plus c refers to the intercept. Alternatively, we can also define this equation as, don't worry, I have explained it in detail over my article. Now, we'll compare the predicted values of X test versus actual values of Y test. The final step is to evaluate the performance of the algorithm using the evaluation metrics, like mean absolute error, MAE, is the mean of the absolute value of the errors. Mean squared error, MSE, is the mean of the squared error. RMSE, root mean squared error, is just the square root of the mean of the errors. I prefer MAE because it gives you the average borderline of maximum prediction range can be. Say, if you have 10 MAE score, that means your prediction will be 10 or close to 10 most of the time. And lesser the score of MAE, MSE and RMSE, the better the model is. That's it. Great. We have successfully completed our first regression model. Bonus. Save the model using pickle and pickle.load to load the model. Another method using joblib. Once you load the model again, you can use it to do the prediction. But remember, the prediction of a new data should contain the same number of features what was used while training the dataset. You can also view them if you are not sure. Just select the model, hit Tab button, and you will see the list of class properties and then select the feature name. Now we will move to the polynomial regression. In linear regression, we need a linear relationship between the target dependent variable and the independent variable. Somewhat should be like this. And what if we don't have a linear relationship? Then we need something to fit the nonlinear relationship between the target dependent variable and the independent variable. This is where polynomial regression comes into the picture. Polynomial regression is a special case of linear regression, where we get a polynomial equation on the data with a curvilinear relationship with the target variable and the independent variable. Now let's feed our data to the polynomial feature. We see this key difference parameter degree equals 2 that will transform x into 3 more features containing features and the square root of features. In one word, we call it as polyfeatures. Then we'll fit the poly feature into our linear regression. Done. That's it. In parallel, we can also create our simple linear regression model for the comparison. Visualize the results. Here we are. We can observe that our polynomial regression is capturing more data than before. Thus, we will conclude polynomial regression is better in capturing and predicting the data than simple linear regression, when our data is nonlinear in nature. Congratulations! We can now successfully apply regression for our nonlinear data. The next is SVR, support vector regression. Support vector regression works on the principle of support vector machine, SVM. In brief, the principal working of SVM is to find the nearest data point, either class, with the help of a hyperplane. This distance is called as margin. Here is the diagram of SVR. Let's understand this with the help of an example. Feature scaling is a must in the support vector, as the whole algorithm is based on calculating the distance between the data points. Thus, feature scaling will reduce the spread of data that will help the algorithm more swiftly and efficiently. Then fit the data just like before. Visualize the results, and here we are. We can observe the SVR is touching more data points than linear regression. Thus, SVR is more suitable for nonlinear data. Next is the decision trees. Decision trees are a non-parametric supervised learning method used for both classification and regression tasks. The goal is to create a model that predicts the value of a target variable while learning simple decision rules derived from the data features. The decision rules are generally in the form of if-then-else statements. The deeper the tree, the more complex the rules and fitter the model. The same code, just we need to replace it now with the decision tree. And here we are. We will see in decision trees, the line is passing between the blue points, thus a better model. However, remember each and every method have disadvantage too for different scenarios. And decision tree commonly face the issue of overfitting when it tries to fit all the data points as much as possible, which later results in biased model. The solution to that is pruning. There is a whole new chapter to optimize the decision trees. So for that, I would request you to visit another blog. Meanwhile, I'll give you an intuition when to use decision trees. DT is used when we are more concerned about the interpretation of our data, like we saw if and else graph, or to generate the rules rather than the accuracy. Time to visualize the decision tree. The tree is finally exported and we can visualize it using this link by copying the data from the tree.file. Here it is. Next is random forest. Random forest is the upgrade version of decision trees. The name itself refers it consists of a large number of individual decision trees that operate as an ensemble. Thus, we are combining the predictive power of several decision trees to give more accuracy. Fit the dataset to the random forest. Visualize it. Well, you can observe from the last data point, the blue point in the decision tree is touching the last red data point than the random forest. Thus, the decision tree here is performing better than the random forest is because the random forest requires more data to generate trees. Well, see, I already told you every algorithm has its pros and cons. In random forest, the algorithm is not affected by outliers and overfitting, but in the decision tree, it does. The only thing left for you is to make a note of the pros and cons of each algorithm that will help you out to understand where to use and not. There are tons of other algorithms to explore. I have listed all of them in my other videos and blog. Link is in the description. Thank you for watching the video. Good day ahead. See ya.